Hello, and thank you for joining us. Today we're going to be talking a little more about graphing exponential functions as transformations of f of x equals a to the x. And in this example, we're going to do a little old school work, and then we're going to show a little shortcut with your graphing calculator and Desmos. So we're asked to graph the exponential function f of x equals negative 1/5 times the quantity of 10 raised to the 1/2 times the quantity of x plus 3 as a transformation of f of x equals 10 to the x. Okay, so they want us to start here with f of x equals 10 to the x. So we'll go ahead and do that. We're just going to think this through. So when x equals 0, that'll be 10 to the 0 power, which is going to equal 1. So our ordered pair will be 0, 1. So we'll go ahead and put a dot in at 0, 1. And then we're going to think about when x equals 1. When x equals 1, it'll be 10 to the first power, which is 10. So our ordered pair would be 1, 10. So let's see if we can do this. 1, 5, 6, 7, 8, 9, 10 is going to be in this neighborhood somewhere here. Okay. And then let's do when x is negative 1. What happens when x is negative 1? Well, it'll be 10 to the negative 1 power. So it will be 1 over 10 to the first power, which will be 1/10. So it's going to be really small. And he's going to be in this area here. Now I know because I've done this, actually I did this video earlier and the audio didn't take. So I'm doing this for the second time, and I know I'm really lousy with this paint thing. So just please keep that in mind. I'm going to try to do the best I can to draw this curve. Okay, touch here, start to curve up, and then really steep, whoa, yeah, not too bad, okay. And then drawing the arrowhead there, and the arrowhead there. And then in this function, we know the further to the left we go, the bigger the denominator of the fraction is going to be. So the x-axis is going to serve as the asymptote. Now, I did all this work before, as I said, and the audio didn't take. So I have this, from this point on, I have this in another paint. So I'm going to just X this thing out. And we're going to go to the other paint. And I put in the word asymptote right there. Okay. And then the next thing we're going to do, instead of going for this big whole thing, we're just going to take 2 chunks at a time. So what I decided to do, since we graphed the parent function 10 to the x, I decided to go for the negative, which is going to give us what? That's going to give us a reflection across the x-axis. And then I decided to go for the plus 3, which is going to be, we know from previous lessons, that the plus 3 is going to be left or right, and it's counterintuitive. So plus 3, we're thinking to the right, it's actually going to know the left 3 units. So let's see if I can if I can just go ahead and reflect over x-axis. Yep, that's where I put in the. Let me pause. Okay, that gives us the words. Okay, so we reflect across the x-axis, and we started at 1, and so that's going to give us these pink dots here, and 1/10 here, and then the 10 is going to be way here off the screen. Okay, so I didn't draw that in. And what I did is I just transferred these pink dots over to this new one, and now they're orange dots. Okay, so it'll go here, here, and then here. And then, so once we're there, then we have to move left 3 units. So now we go from orange here to 1, 2, 3. It'll be right here at negative 1, 2, negative 3, negative 1. And then this dot is going to be, it's going from negative 1 to negative 4. So that'll be negative 4 and 1/10. And then we know when we're at negative, when x is -2, it's going to end up down here. Okay, and then the asymptote's still going to be the x-axis. So I'll do all this drawing. I'll just fast forward it. I mean, whatever. I'll put it on pause just a sec. Okay, so what I did is I labeled the asymptote here, and I just put these light blue dots in where we just discussed. Okay, and then I'll pause again and put the curve in. Okay, so I drew my curve in, and I apologize for how shaky it looks. So that's what the curve looks like now with these two transformations, the minus and the +3. The minus. So our understood value here for b is going to be 1. It's an understood 1, but it's negative. That's the reflection. Okay, so what do we add in the very last thing? We just put the rest of the stuff in. So here we have the 1/5, and so the 1/5 is going to do a vertical shrink. So it's going to compress it vertically, and then the 1/2 is going to do a stretch. Remember, these things up here in the exponents are counterintuitive. So it's going to do the 1/2 is going to do a horizontal stretch. So I'll go ahead and put those words in for you. Okay, at this point we know we're going to have a vertical compression and a horizontal stretch. So we're going to go and get a little help from our friend the graphing calculator. Okay, so let's enter this equation in under y equals. So y equals negative 1/5 times the quantity of 10 raised to the 1/2 times the quantity of x plus 3. X plus 3. And close parenthesis. I like to scroll down. Okay, so now what we can do is we can go ahead and graph. We can graph that. And this is, I think, set in standard mode. So if we wanted to zoom in a little bit on this, we could zoom, maybe box it in. That might be a good idea. Or zoom in, play with it a little bit. Why don't we just go and box it in? Okay, so our box is going to, we don't have to go very tall with the box. We just want to get a nice part of the curve here that looks good to our eyes. That sounds good there. And then we can come over here to the right, create our box. Maybe I went too far. I'll probably come back over to the left a little bit. Okay. Yeah, it doesn't really matter. Okay, that looks good. So now we can see the curve very nicely. We see where it's going to cross the y-axis there. If we trace, we can see that actually the value of x gets close, moves to the left, more negative and negative. The value of y, notice the value of y, gets closer and closer. Well, what am I doing? Gets closer and closer to 0 as we keep scrolling. So we know that the x-axis is going to serve as our asymptote. Why don't we go ahead and we could calculate some values. Why don't we calculate second calc? When x equals 0, that'll give us the y-intercept, a value. When x equals 0, enter. Y is going to equal negative 6.32, whatever. So why don't we just jot down an ordered pair of 0, comma, negative 6.3. For our hand graphing, it's not going to matter. We don't have to be so very accurate. Okay. But then let's look at the table so we can find some actual whole numbers to work with. So we can go to second table here, and we can see, okay, well, it looks like when x is negative 3, we have y is negative 1/5. So our ordered pair is negative 3, negative 1/5. When x is negative 1, y is negative 2, so our ordered pair is negative 1, negative 2. And then we have 1, negative 20. Well, that's going to be off our graph. Okay, so we can plot those points. Why don't we go ahead and plot those points on our handwritten graph? So we would have what's the first one we can put right here? We can put x is 0, and then it's going to be a little greater than negative 6, negative 6.3, so right around here in green we'll put it. The next one we can put at, our ordered pair was negative 1, negative 2, negative 1, negative 2. Okay, the next ordered pair we can put, well, when x is 1, it's negative 20, so it's going to go way, way down here. So the end behavior of this is going to kind of come like this. And then what should we do? One more. When x is negative 1, 2, 3. When x is negative 3, it's negative 1/5. Okay. So here we go. We can see that the asymptote is still going to remain. We know that the asymptote is going to be the x-axis. So we will carefully do the best we can to draw on the curve. Let's see how well I did. Fair. Okay, so this is our hand graph, and with the help of the calculator, I do want to show you Desmos really quick. Let me hit pause. Okay, so this is Desmos. You can use this tool to check your work. Certainly, you're not going to have this wonderful resource on an exam or anything, but it's certainly a wonderful tool to check your work and help you visualize things. So we're going to go ahead and enter in the 3 different equations we graphed by hand. First, we graphed 10 raised to the x, and okay, so there's 10 raised to the x. And the next thing we did is we added the negative in front of the 10, and we did the plus 3 out here. So the neat thing about this is, as you type it in, you can see what happens to the graph as you type. It's really neat. So we have negative 10 raised to the quantity of x. Okay, so that already gives us the reflection we started with. And then we had the plus 3. So we were going to go to the left 3, remember? So plus 3. Sure enough, that's what happened for us. Okay, and we can go and check some of our dots by simply holding, what I'm doing is holding the mouse button, the left mouse button down as I trace these. That's the way Desmos works. So it's a lot of fun just to kind of kick around with. You can put a couple graphs at a time. I don't know how many. Most I've had is like 3, I guess. But all right. So then the next one we're going to do the Mac Daddy one, which was the quantity of negative 1/5. Negative 1/5. Oh, it's giving me all these. Maybe I don't have to do much typing here. Okay, negative 1/5. Maybe that's too many parentheses. I'm not too sure. Why is that? Now, here we go. Okay, negative 1/5 times the quantity of 10 raised to the 1/2 times the quantity of x. Alright. Okay. So there's Desmos, and once again you can scroll and check your work. Do we do well? I think we said Negative, didn't we say -1? Sometimes it's hard to get it to show exactly. Yeah, -1, -2. And I'm pretty sure that's what we did. -1, -2, there we go. And then it was a little, the y-intercept was a little, like -6.3, something like that. Okay, so here we are. Yep, 0, -6.325, dot, dot, dot. Okay, so there you go. There's Desmos. And we did it with your graphing calculator, with Desmos, old school, most of it. Sure, we could have done this old school all the way if we wanted to. It would have just taken us a little, whatever, not too many more minutes. But hopefully that's helpful for you, and hopefully you've learned something about graphing exponential functions as transformations of f of x equals a to the x power. Thank you so much for your time, and we look forward to seeing you on the next section.